Good afternoon, class. Welcome to Notes 5.3, Solving Trigonometric Equations. Now, I want to remind you that you have been solving equations all of your life. You have been solving things that start like x plus 2 equals 5 and isolating x. Today, your goal is going to be to isolate the trigonometric function involved in the equation. You will use algebraic techniques such as collecting like terms and factoring in order to solve these. Now, once we get into quadratics, things will get a little bit more interesting because there are a variety of ways to solve quadratic equations. So today when we focus on quadratics, they will only work one way. In the next class, they will start to diverge into some other options. Okay, so the rules. The first rule is that you need to isolate the trigonometric function. The second rule is that you need to collect like terms. Starting with example 1, we are not going to solve. It says verify that x is a solution. So on part A, they give you x equals pi over 3, an angle, and then they give you an equation, 2 times the cosine of x minus 1 equals 0. So all we have to do is substitute pi over 3 in for x. You do not need a calculator to do this. You can do this all in your head. 2 times the cosine of pi over 3 minus 1 equals 0. Verifying means show your work. So 2 times the cosine of pi over 3. I'm looking for the x value at pi over 3. That's 1/2. Minus 1 equals 0. 2 times 1/2 is 1, minus 1 equals 0. And when we verify, that means that the left should equal the right. 0 equals 0. It's a true statement. Looking at part B, I've decided to skip this question. You could use your calculator to verify pi over 12. Aside from that, we're not going to do that problem. Example 2. Find all the solutions of the equation in the interval starting at 0 and including 0 degrees going to 360 degrees, but we're not going to include 360. So therefore, if the answer is found at the positive x-axis, then our answer would be 0 and not 360. These equations are very simple because the trig function is already alone. It's already isolated in both of them. So I can go ahead and start my problem. To do this, it's saying tell me the angle where the y value is 1/2. Tell me the angle where the y value is 1/2. Now, if you wanted to, you could think of this as an inverse problem. You could say inverse sine of 1/2 is equal to x, which is the angle. So where on the unit circle, when you do inverse sine, you can only use the right side of the unit circle. Where's the y value equal to positive 1/2? Well, we are at pi over 6. Now, unfortunately, or fortunately, it asks us to report that in degrees. So we are 30 degrees. Since we're always expecting you to think a little bit further, that was the answer to the inverse sine problem, but they gave us a different stipulation using 0 to 360. So is there another place where the y value is positive 1/2? The answer is yes. The y value is also 1/2 over here at 5 pi over 6, which is really close to 180, so it's 150 degrees. So your two answers for this question, x equals 30 degrees and 150 degrees. So you have multiple tasks here. Not only do you have to solve the problem, but you have to report it the way that they expect you to report it. Go ahead and hit pause on your screen and try part B. You should be very used to figuring out where tangent is equal to 1. I'll go ahead and let you hit pause and try it on your own. Okay, here we are with the tangent of x is equal to 1. So I am looking for the inverse tangent of 1. What angle is it? Okay, this is saying find the angle. It's screaming at me, find the angle. Okay, so if I'm a tangent problem, the way that I think about this is that I need a positive tangent value. So I either have to be in the first quadrant or I have to be in the third quadrant. Okay, now if it's an inverse tangent problem, I can only use the right side of the unit circle. So it looks like my answer is going to be in the first quadrant to start with. So if tangent is supposed to be 1, I need to know where y over x is equal to 1, and that tells me that my y and x value need to be exactly the same. Well, that occurs at 45 degrees. Now, paying attention to what this problem is asking for, I need to go ahead and answer another place because I'm going all the way around the unit circle, another place where inverse tangent is equal to 1. So 45 plus 180 degrees is 215 degrees. So your answers in this problem are x equals 45 degrees and 215 degrees. You know what? I made a mistake, and I knew I did. I could feel it. 225 degrees. And you know what? I was ready to make a mistake, and I'm glad I found it before I moved on. So just make a correction. I hope you found it before me. 225. Okay, moving on to example 3. Find all solutions of the equation in the interval 0 to 2 pi. Same type of idea, only this time we're in radians. So once again, you can read this question in two ways. You can look at this and realize that when you have a trig function, normal trig, cosine, you always have to have an angle next. So x represents an angle. So where is the x value on the unit circle of root 3 over 2? Or you can change this and do the inverse cosine and think about that first. It's the same idea. So I need to know on the top of the unit circle for inverse cosine where the x values are root 3 over 2. Well, they are root 3 over 2 right here. And I get to use the entire unit circle because of my stipulations. And down here, I am answering in radians, so this is pi over 6, and this is 11 pi over 6. And those are my two x values that would work in this equation. Go ahead and try the next two on your own. Hit pause and see if you can do these on your own. When the secant of x equals negative 2, I am thinking about a cosine value because secant is directly associated with cosine. So 1 over the cosine of x is equal to negative 2. And I know that in order for that to happen, my cosine value needs to be negative 1/2 in order to get the reciprocal negative 2. So where are my x values negative 1/2? On the full circle, x values are negative 1/2 up here and down here. So those angles would be x equals, in radians, 2 pi over 3, and x equals 4 pi over 3. 2 pi over 3 and 4 pi over 3. Last problem, tangent of x equals root 3 over 3. I look at that problem and the first thing I notice is this radical 3. What I am thinking is that tangent is equivalent to a y over x. So I know that I have to have a root 3 and a 1/2 in this problem. From experience, we know that the root 3 over 2 should be on the bottom because when we simplify this, it'll be 1/2 times the reciprocal of the bottom. That will give me 1 over root 3, and then rationalized equals root 3 over 3. We've been working on these for quite some time. So now on the unit circle, tangent has to be positive. So I'm in the first quadrant or the third quadrant. My y value is 1/2, or my y value could be negative 1/2. So the answers to this problem, x equals y value of 1/2, x value of square root of 3 over 2, that's pi over 6. And x value, y value of negative 1/2, x value of negative root 3 over 2, that would be 7 pi over 6. One notation for this type of problem is to show this one would be positive and this one would be positive, or this one would be negative and this one would be negative. If you're interested, now would be a good time to maybe take a break. You don't have to, but I thought I might humor you with some animal videos. If you'd like to go to this website, it's one of my favorites about dogs. Now, everybody's always saying that we should watch cat videos, but I feel like the dogs are always getting left out. So this one's just kind of cute about a dog who really can change his barking up quite a bit. So if you want to watch it, go ahead. If not, we're moving on. Now we are ready for some of the more interesting problems. First one, you need to take these very slowly and really think through them. In this problem, there is one trig function. It's cosine. I need to isolate that cosine. And you would do that using basic algebra rules. We are going to add 1 to both sides. So 2 times the cosine of x equals 1. Then we are going to isolate by dividing both sides by 2. So the cosine of x equals 1/2. You're not done. You are supposed to find where this works. And it says solve the equation, and it gives us no restrictions. That means we have to answer with everything we know. And I hope that when I say we need to answer with everything we know and everything on the unit circle, I hope that something's coming to mind, and it's our buddy n. So let's get used to that. Okay, so right now I am looking for, I'm going to use inverse cosine because I'm comfortable with inverse cosine. I'm trying to find the angle where the x value is equal to 1/2. So I am going to draw on my unit circle x values of 1/2. So x value of 1/2 occurs right here, and it also occurs down at the bottom. Okay, now here's how we're going to report this. If we can beat any coterminal angle with this one, then x is equal to the angle pi over 3. Technically, I'm not finished with part A. Sorry, I got stuck in the middle of a phone call. Okay, here we are looking for the x values that are positive 1/2. So I am up in the first quadrant and I'm in the fourth quadrant. Now, if we want to say that we can be at pi over 3 or any multiple of pi over 3 going around the unit circle, in order to get back, we'd have to add a full 2 pi to get back here. I'll show you that. If we wanted to get back here, we'd have to go one full circle, which would be 2 pi. So pi over 3 plus any multiple of 2n pi. And I know that you guys would probably like to see n 2 pi, but that's not really how we write math. Usually we put the number and then any variables. Okay, so then this value down here, this x value, this is x equals, that would be 5 pi over 3. And if we want to get back all the way around there, we'd have to jump all the way around 2 pi. And it won't always be 2 pi, just so you know. So 2n pi. Remember that n is defined as an integer. So if it were 0 in this case, we'd be at 5 pi over 3. If it were 1, we'd be at 5 pi over 3 plus another 2 pi. So it always works. So these are your two answers, and you need to get better at working with n. Part B. Technically, this equation is quadratic. I want to show you why. Sine times sine is sine squared x. Sine times -1 is negative sine of x. So this is a good lesson for your first quadratic experience. When it's quadratic, one of the options will be to factor. This one has already been factored for you. So it's a factored quadratic. Now, you guys have done a problem like this many times. X squared plus x equals 0. A quadratic equation, how do you solve this? Well, if you factor in x, a GCF out of both terms, you'd get x plus 1 equals 0. So you guys remember saying this first part could be 0, or the second part could be 0. In that case, x can equal 0 or x can equal -1. So that's what we have up here. Either sine of x can equal 0 or sine of x minus 1 can equal 0. So I'm going to go ahead and get rid of this so I have some more room. And I'm going to go ahead and finish the problem. So when you see this, each factor, sine of x can equal 0 or sine of x minus 1 can equal 0. Here we go. So where is it that my y values are 0? My y values are 0 here and here. Now let's watch how we make a rule. Our x can equal 0 plus, in order to get over to this angle right here, I only need to go pi. To get back, I'd go 2 pi, 3 pi, 4 pi. So I want my n's to be 0, 1, 2, 3, 4. So it'll just be x equals 0 plus n pi. And that would simplify to n pi. On the next one, add 1 to both sides because sine needs to be isolated. So sine of x equals 1. Where on the unit circle are my y values equal to 1? Up here only. So x is equal to pi over 2. And then in order for me to get back up there, I'd have to go all the way around to full 2 pi. So it'll be plus 2n pi. So this is an answer for this problem and also x equals n pi.